far below the surface, the ocean is not silent. At that time, scientists believed the deep sea was mostly quiet, except for earthquakes and whales. But something unexpected happened. Hidden underwater microphones, first used to track submarines, began picking up sounds no one expected. These signals traveled across entire oceans. Some were louder than any known animal. Others repeated again and again over the years. Soon, everything changed. Researchers realized they were hearing something they could not fully explain. Over the years, more of these sounds were recorded. Each one is different, each one coming from the dark, unseen depths. However, the story did not end there. Even today, some of these signals remain a mystery. So, the question remains, what is really making these sounds deep beneath the ocean? At that time, the ocean was being listened to for a very different reason. During the Cold War, the United States built a secret system called SOSUS, designed to detect submarines moving silently underwater. Long lines of underwater microphones, known as hydrophones, were placed deep in the ocean. Years later, this data was shared with scientists from NOAA. What they found was unexpected. These hydrophones could detect low-frequency sounds traveling across thousands of kilometers. Sound moves faster and farther in water than in air, turning the ocean into a vast listening field. Over the years, researchers began sorting through the recordings. They filtered out familiar noises, ships passing by, submarines on patrol, even earthquakes deep beneath the sea floor. But something didn't fit. Some signals remained. They didn't match any known source. They were too powerful, too strange, or too consistent to ignore. However, the story did not end there. As more data came in, one signal stood out immediately. In 1991, scientists listening to the vast Pacific Ocean noticed something peculiar. At that time, hydrophones operated by NOAA were mainly used to track submarine activity and monitor routine underwater noise. Most signals were predictable: whale calls, distant earthquakes, or passing ships. But this sound was different. It didn't flare up once and vanish. Instead, it returned again and again, echoing through months and even years. Each time it appeared, it followed the same rising pattern, almost like it had a rhythm of its own. Scientists could trace it across thousands of kilometers, confirming that it wasn't a local anomaly. They gave it a name, the Upsweep. Inspired by the way its tone climbed upward like a steady musical scale, stretching over the quiet, dark waters of the Pacific. The acoustic signature of the Upsweep was remarkable. Unlike most ocean noises, which are broad and chaotic, this signal stayed within a narrow frequency band. Its rise in pitch was gradual and smooth, forming a continuous sweep rather than a sharp spike. The repetition was striking. Every cycle mirrored the last with almost surgical precision. This made the Upsweep stand out against the chaotic backdrop of the ocean, drawing attention from hydroacoustics experts around the world. What baffled scientists even more was its seasonal behavior. Recordings showed that the signal intensified during spring and autumn, then faded slightly during other months. Natural underwater events rarely follow such a predictable, repeating schedule, making the upsweep a persistent mystery. Researchers began tracing its source to remote regions of the Pacific, particularly near underwater ridges and seafloor volcanoes. Geological activity, tectonic shifts, magma movement, or hydrothermal venting could explain some of the energy behind the sound. Yet, the seasonal pattern remained unexplained. Why would geological processes occur with such clockwork timing, year after year? The upsweep challenged the assumptions of what we know about underwater noise. Even with a plausible geological explanation, the behavior and consistency of the signal suggested there might be more at play. Some scientists began considering alternative possibilities. Could it be a call from an unknown species of deep-sea creature? Could interactions among large-scale ecosystems produce such structured acoustic patterns? Decades later, the upsweep continues to be recorded, repeating its mysterious sweep across the Pacific. No definitive answer has been reached. The upsweep echoes like a whisper from the deep, a repeating enigma that refuses to be fully explained, hinting at the ocean's hidden and largely unexplored mysteries. In 1997, hydrophones scattered across the South Pacific picked up a sound that stunned scientists. At that time, NOAA researchers were accustomed to hearing whales, distant earthquakes, and the faint hum of ocean currents. But this signal was different. It was enormous, so loud it registered across thousands of kilometers, dwarfing any marine sounds previously recorded. The first recordings left the team speechless. For a moment, no one could categorize it. Was it geological, biological, or something else entirely? The sound was so powerful and unusual that it demanded attention. Researchers quickly gave it a simple name, the Bloop, after the way its rising tone seemed to pop into existence in the recordings. Unlike anything heard before, the Bloop instantly became a symbol of the deep ocean's unexplored and unpredictable nature. The Bloop's acoustic signature was startling. It was a low-frequency sound that surged sharply, climbing rapidly in pitch before fading out. Its structure was oddly deliberate, almost like a signal produced with intention, not by random forces. The sound's reach was extraordinary, detected by hydrophones spaced thousands of kilometers apart. At first, this suggested something unimaginable, a creature of colossal size or a seismic event of unprecedented scale. Scientists compared it to whale calls, earthquakes, and volcanic tremors. But none matched the energy, pitch, or pattern. The sound seemed alive in a way that geological events rarely are. It blurred the line between natural phenomena and the unknown, leaving researchers both excited and puzzled. After thorough investigation, the most widely accepted explanation emerged: icequakes. Massive Antarctic glaciers, cracking and shifting along the continental shelf, can produce enormous energy bursts. When these icebergs grind against the seafloor, the resulting vibrations can travel across vast distances, producing sounds detectable thousands of kilometers away. This explanation satisfied part of the mystery, confirming that the bloop was likely geological rather than biological. Yet, many questions remained. The sound structure resembled living patterns, and its intensity was far higher than typical ice-generated noises. Why did it mimic biological calls? Why did it resonate with such clarity across such vast distances? Even decades later, the bloop echoes through recordings, challenging our understanding and inviting us to wonder what might still be lurking in the unexplored depths. In 1997, hydrophones in the Pacific Ocean recorded a sound that immediately drew the attention of NOAA scientists. At first listen, it was strangely familiar, like a distant train rolling steadily through a quiet night. Unlike whale calls, earthquakes, or ship engines, this noise had a long duration and a structured rhythm. Each pulse repeated with startling regularity, forming a pattern that seemed deliberate rather than random. The signal stretched across thousands of kilometers, picked up by multiple hydrophones, and persisted for hours at a time. It was unlike anything researchers had cataloged before, earning the nickname train. The acoustic properties of train were remarkable. It carried low-frequency energy, but layered it in a way that gave depth and texture, almost mechanical in quality. The pulses weren't chaotic. They moved in sequences, rising and fading with a rhythm that made the sound feel alive, yet machine-like. Scientists initially struggled to match it with any known natural or biological source. Nothing in marine biology, seafloor geology, or glacial activity perfectly explained the structured repetition or the strangely mechanical feel of the sound. After months of study, the leading explanation pointed to massive icebergs moving along the seafloor. As these enormous blocks scraped over underwater ridges and slopes, friction produced continuous, low-frequency vibrations. These vibrations could travel thousands of kilometers, creating the long, persistent, and surprisingly patterned signal recorded by the hydrophones. While this explanation accounted for the volume and persistence of train, it didn't fully resolve the mystery. Why did the sound feel so structured and deliberate? Why did it so closely resemble machinery? Alternative possibilities still spark curiosity. Some scientists speculate that unknown underwater movements, perhaps related to tectonic shifts or sediment flows, could produce similar signatures. Others suggest the involvement of deep-sea biological activity, a species or ecosystem producing rhythmic, coordinated sounds we have yet to observe. Even decades later, train serves as a reminder of how little we truly understand about the deep ocean. Each recording hints at hidden processes, echoing across the abyss, and leaving researchers and listeners wondering what lies beneath the waves. In 1999, hydrophones in the equatorial Pacific picked up a short, low-frequency sound that immediately piqued the curiosity of NOAA researchers. At that time, scientists were already familiar with the unusual underwater noises, whale calls, ship engines, or distant tectonic rumblings. But this signal was unlike anything they had heard before. It lasted roughly 15 seconds, smooth and steady, almost pure in tone, and echoed faintly across thousands of kilometers. Its consistency was remarkable, yet its source remained elusive. Researchers quickly named it Julia, after the waveform's subtle elegance. Despite its brief duration, Julia stood out because it was clear, structured, and different from the chaotic sounds of the ocean floor. The acoustic characteristics of Julia were intriguing. Its waveform was sustained and uniform, creating a tone that was easier to isolate from background noise than most other deep-sea sounds. Initially, scientists compared it with ice-generated signals, like icebergs grounding or scraping along the sea floor. In many ways, it fits the general pattern of these geological noises, suggesting a plausible explanation. However, unlike previous signals, such as the bloop or the train, Julia's origin could not be visually confirmed. No camera, submersible, or satellite ever verified the source, leaving the signal unconfirmed and mysterious. This uncertainty opened the door to other theories. Some scientists propose that Julia could have been produced by an underwater landslide or a sudden geological shift, sending energy waves through the surrounding water. Others speculated about rare biological events, imagining an unknown deep-sea organism generating this low-frequency tone. The smooth, structured nature of the signal made it difficult to dismiss entirely as geological. Could it be a species we have never observed, communicating or moving in ways that generate these precise sounds? Each theory seemed plausible, yet none could be fully confirmed, keeping the mystery alive. Decades later, Julia remains an enigma. Unlike the bloop or the train, its source has never been definitively traced. The signal serves as a reminder of how little we truly know about the deep ocean. It highlights the limits of our observation tools and the vastness of the unexplored abyss. Even now, Julia continues to echo faintly in hydrophone recordings, a whisper from the ocean depths that refuses to be fully explained. All the mysterious ocean sounds share striking similarities. They travel across thousands of kilometers, remain in the low-frequency range, and release an extraordinary amount of energy. At that time, scientists could only rely on sound to study them. The deep ocean is nearly impossible to explore directly. Extreme pressure, darkness, and vast distances limit observation, leaving hydrophones as the primary tool to listen in. Because of these limits, many questions remain. Are some sounds biological but misidentified as ice movements or geological events? Could there be unknown species producing ultra-low-frequency calls that we have yet to discover? Are these signals just a small fraction of the ocean's hidden activity, hinting at a world we barely understand? Despite decades of research, the ocean continues to keep its deepest secrets, reminding us how much remains unexplored beneath the waves. If you enjoyed diving into these mysterious sounds and want to explore more of the ocean's hidden wonders, make sure to subscribe and hit the notification bell. The deeper we listen, the closer we get to discovering what truly lies beneath the waves.